Section 115 discusses variation, and there are three types of variation that we'll discuss. Therefore, we will have 3 videos for this section. The first type of variation that we'll discuss is the easiest, and this resembles the proportion that we talked about before. Direct variation says that if x and y vary directly, then there is a proportionality constant k such that k equals x divided by y. And like I said, direct variation looks like a proportion, and we can think about d division gives us direct variation. So if you consider the following example, you've got 4/6, which reduces to 2/3, 10/15, which reduces to 2/3, 6/9, which reduces to 2/3. All of these reduce to 2/3. So in this case, our proportionality constant is 2/3. And so for every increase of 2 in the y value, we get an increase of 3 in the x value. So let's look at some examples of when this happens. The circumference c of a circle varies directly with the diameter. So if we wanted to find k, this would be the circumference divided by the diameter. And if you want to know what this value actually is, I'm sure you've seen that the circumference is equal to pi times the diameter, if you wanted to find that value. So in this case, if we divide both sides by d to solve for pi, we end up with pi is equal to c over d. So in this case, our proportionality constant is actually pi. Now this isn't always going to work out this way, but it's good to know that that's what pi means. It's this ratio of the circumference of a circle to its diameter. Let's look at another example. It says the power of an engine varies directly with the square of the radius r of its piston. So let's write that down first. K is equal to, so this is varying directly, we're going to have division. The power P varies directly with the square of the radius. So in this case, we're going to have radius squared. That's the only difference, is we are told that it needs to be the square of the radius. So now, given the information, if 40 horsepower engine, so 40 horsepower engine has a piston of radius 2 inches, so 2 squared, this would be equal to what power does the engine, so we're going to find the power of radius 4 have, so this would be 4 squared. So again, whenever we're dealing with direct variation, this is the same thing as setting up a proportion. So we end up with 40 times, well, 4 squared is 16. This is equal to P times 4. If we divide both sides by 4, we end up with P being equal to 160, and our units are horsepower, that HP. So again, we can set up these proportions because we know that the direct variation are always equal to the same constant, so therefore if we keep setting up the same ratio, we can set those ratios up equal to each other. Another example here, Charles' law states that if the pressure on a gas is constant, its volume V varies directly with absolute temperature. So in this case, K is equal to, well, if V varies directly, so it would be V divided by T, the absolute temperature. We can also multiply this T over to the other side and get this to be written as V equals KT, where K is the proportionality constant. Now this last example here deals with inverse variation, which we'll talk about in the next video, so we'll come back and look at this example. So this concludes the first video for section 115, which dealt with direct variation. The next video will discuss inverse variation.